Good afternoon. This is our gun violence analysis by Genesis generators. In this presentation, we'll be going over our why, our hypothesis, our MVP, our tech stack, what type of AI problem we have, feature and target variables, as well as graphs, machine learning models, conclusion, potential roadblocks, as well as future scope. So for our why, we would like to say that there's like a lot of use cases for something that would have something related with gun violence, and how gun violence is something really pressing and it's a prominent issue in society. And we really wanted to use AI to be able to do something to help people and hospitals know how many people would be hurt by something like this in a incident and be able to prepare for that. Our hypothesis was that we wanted to be able to predict the number of people injured and relay this information from police to those hospitals so they would be able to help as many people as they can, and many people could not be hurt too much from this incident. Our MVP is that we wanted to have visualizations to help understand the data at hand, have a prediction feature that would help people know how many people would get injured in an incident, and create a front-end website to tie this all together and present this information. For our tech stack, we used Python, sklearn, Plotly, NumPy, Pandas, Jupyter Notebook, HTML, CSS, and Bootstrap. I'd like to pass it on to my teammate Hyushu to continue.
Okay, so all AI models are either classified as a classification or regression model, and ours is a regression model. Okay, so some features that we had in our data set were like the number killed, participant descriptions like gender and age, the state that the case was in, and the type of gun. And then the target variable was the prediction of the number of injured. So our graphs. So our first graph was a bar graph that compared deaths per year, and it was over the time span of from 2013 to 2018. Our second one compared injuries per year. Our third one was injuries per state. And one thing we noticed that was important to take into account was that each state had like their own like population and population density. So when looking at like the number injured, it was important to like look at like the places with larger population would have more injuries overall. So now passing it on to my teammate Inay.
Okay, so our first bar graph shows the number killed per state. One thing to notice while looking at this is that California has the highest population density, while Vermont has the lowest, and these factors can affect the number of deaths in the area. Okay, next we have a scatter plot, and this was used in trying to predict the guns involved in killing. This shows our data set is not 100% accurate, as there was 400 guns used in a killing, which is highly unlikely. Okay, next we have a Choropleth graph, and we use this because you can visualize the data rather than looking at the numbers. Okay, now we are on to our models. So our first model is going to be a linear regression one, and we used it to find a correlation between different features. And we got a mean square error of about 0.393 from this model. And now I'm going to pass it on to Elijah from here.
Our second model is a gradient boosting. It is an ensemble model, and we obtained a mean square error of about 0.347. Our third model is a random forest. It is a combination of multiple decision trees, which is why it's named random forest. We got a result of about 0.346 for our mean square error for this model. To pass it on to our next teammate, Ellis.
To conclude a project, our models were off because each incident was different. There are not only physical statistical aspects of this, but there's also psychological aspects. Due to the data set, our models did not perform as well. Though this is a prominent issue, there are not many good data sets about this in different platforms. So as every project or whatever goes, there's all these roadblocks and stuff. So in our case, it's gun violence is very unpredictable, especially in the United States. And the sources like Pew Research or BBC had very different results from each other, which made it a hard topic to cover because of chaotic data and the frequent rate of the crime. With the future scope of this is with more awareness for gun violence, we can make new, more reliable models that can help people in the future. With this type of technology having an important use, having good data is very important.
Thank you for listening. Now let's move on to our website. For this, we wanted to really explain how we went about in creating this website. So we wanted our top section to have information that we found important. So these are our important headers. And we wanted to create an integrated way. So when you click on each of the headers that you want to see, you would be able to reach the section that corresponds with it. So you can get more information about which parts you want to look at. So for example, if you clicked on hypothesis, you would be able to reach the hypothesis part. And like so, you can click on why and you'll reach there. So to move on, we would like to say that to add on to whatever we wanted to say in the beginning about why, we wanted to create something that would help with gun violence, and not only the aspect of the scene, we wanted to create something that would help you be proactive in saving as many people as you can. So, so this was something from the aspect of hospitals and how the hospitals could react to some situation like this in the future. For a hypothesis, based on our why, we wanted to create something that would predict the number of people injured based on various features that you can input into our model, like gender, age group of the participants, and be able to relay this information about what you get, so the number injured, to the hospital so they can prepare and get ready and save as many people as they can. So we have our MVP, our tech stack, and the fact that this is a regression problem. With the feature and target variables, which are all the description that you have, that the police would have about the incident. And the output or the target variable that we were looking at would be the number of people injured. The next thing that we really liked about the layout about this website was the fact that we could have a graph on one side and a description of the graph on the other side. So in this example, we have our bar graph on the right side, which shows the year and the number of kills in that year, along with the description about the bar graph. So in this bar graph, you can hover over it to see the amount of people killed in different years. And as you can see in this layout, it changes. So the graph would be on the left side with the description on the right side. And this bar graph is pretty similar to the previous one, but this one has the injuries versus the year rather than kills. So our third bar graph basically describes the injuries per state. So we also wanted to have a graph that would show the different amount of injuries per state instead of just the year. So here we have Illinois with the most amount of injuries, but we also wanted to highlight the fact that population density is different in each state. So there could be some discrepancies, and maybe that could be a little different than what is shown. So our next bar graph is pretty similar to the previous one, and this one shows the kills per state. In this bar graph, you can also see that it is interactive as well, and it shows the number of kills per state rather than injuries like the previous one. We also decided to include a scatter plot, which shows different features and how they affected everything. So for this, we had something that was really highlighted in our data set. So there were many outliers in our data set, which made it hard for the AI models to be implemented properly and create accurate models. So you can see this in real time because over here you can see like 400 guns were used in a particular scene. While we don't know if this is true, it does seem like an outlier. So because of this, you can see that our AI models did not have the best accuracy. For our Choropleth map, we wanted to create a map that shows the total amount of injuries per state in a visual manner. So for this Choropleth map, you can see everything in a way that shows the relative amount of injuries per state. So everything is like easy to compare next to each other rather than having just numbers. We use the AI models linear regression, gradient boosting, and random forest for this project. And to wrap it up, we would like to talk about a conclusion. So we wanted to describe how our models are off because each incident is different in gun violence, and how there's also psychological aspects and not everything is physical, like the ones that the data set and our project is considering. So due to this data set, we did not have models that performed as well as we would like them to, but we wanted to highlight the fact that this is a prominent issue. And since there are not many good data sets in different platforms, it was a little harder for us to cover. And also, we wanted to go over the fact that gun violence is actually very unpredictable, and especially in the United States. So different sources had different information, and it was very hard to see which information was correct and which one we should use. So there were some discrepancies in what really happened and what should have happened. So some future scope for this project could be that with more awareness for this problem, we can create more new reliable models that can help people in the future. So with this type of technology and with cleaner data sets and data sets that highlight everything, we could create technology that has really a good use case in society and be able to help people, like more people be saved from gun violence. So down here we have our teammates. So I'm Srilavanya Chitty, and I am a student in Matia Valley High School. I enjoy reading books and writing in my free time. I'll pass it on to Ellis to talk about a little more about himself.
Yeah, I'm the guy on the internet who has access to a computer. Really nothing much here.
I'm just trying to learn more about my interests, and I got a Clark. Elisha can go next.
And I just do research on different technologies.
I go to the project.
Thank you for watching and listening.